Welcome to an example in which we're looking at a function here, and they want us to find all the zeros, all the places where the graph of this function hits zero, hits the x-axis. And they tell us that one of the x-intercepts is -3, enter all of them separated by commas, exact values, not decimals. Okay, how do we do this? Well, first off, let me just show you the answers. So I've got it graphed, and then I'll show you how we get them without using a graphing tool. So if we come in here, here it is. Here is the graph. You can see over there, if I've gone to desmos.com, and that's one of many really good graphing sites, and they have a nice graphing calculator. I just graphed our function. And you can see it, indeed, it does hit the x-axis. Here's a picture of that graph. It does hit the x-axis 3 times, doesn't it? Going up, down, and then back up. Now, what are those points? Well, if you kind of focus in, you can see them, especially if I tap them here. There they are. There's the 3 places that our graph, our function, hits the x-axis. One of them's at -3, and the other 2 are kind of weird numbers, -0.732 and 2.732. And it's not, by the way, you can't, even if we did use the graphing tool, we can't just type in those decimals because the problem said exact answers. Those are rounded decimals. The decimals actually go forever at those locations. And even Desmos can't tell you the exact answer. So we have to get it using the techniques I'm going to show you. But notice one of them is just at -3, and that's the one they gave us. And then the other 2 we're going to have to find using these techniques. Okay, so let's do it. Back to the question. Here's the function. There's the -3 that we saw in the graph, and then we have to find the other 2, notice exact values, not decimal approximations. But those were decimal approximations we just saw. Okay, how do we do it? Well, here's the notes. So the notes on this topic say, step 1, do synthetic division, and then get the answer you get from that. Now do the quadratic formula on that. It's because we're breaking something down. You know, it's kind of like, this is always the analogy. It's like if I said, hey, I'm going to start with the number 30, and I'm going to say, by the way, 5 is a factor. 5 is one of the things that goes in. Find all the things that goes in. Well, what would you do? You would do long division. You'd go 5 goes into 30. You'd go 6 times, 6 and 5, 30. Remainder 0, of course, goes in perfectly. So then you say, oh, okay, so 30 is 5 times 6. They gave you the 5. So the 5 is done. Then you go, okay, now I got to break down the 6. So you go, oh, that's 2 times 3. So there we go. There's the 3 things that make up a 30. Well, that's kind of like what we're going to do for this big old polynomial with x's, just like we did for the 30 with numbers. Same idea. So the first step, as it says, step number 1, synthetic division. We're going to divide. It's called synthetic division because it's fake division. It means shortcut. We don't have to do the whole long division. We're going to do the shortcut. So let's do it. So then you grab the -3 here, and that goes out here. And then you grab the other coefficients and you put them down. There's a 1 there, a 1 there, a -8 there, and a -6 there. Right? This is why it's called fake division. We're not writing the x's, we're just doing the numbers. It's shortcut division. Okay, remember how synthetic division works? You bring down this number, and then you go -3 times that. You write it right there, is -3. And then you add these up. 1 and -3 is -2. And then you do it again. -3 times -2, and it goes right there, is +6, right? 2 negatives multiplied to be positive. And then you add these up. -8 and +6 makes what? -2 again. And then you do it again. -3 times -2 is +6. Add these up. No surprise, it's 0. That's our remainder. You always get remainder 0 when you divide by something that goes in evenly. Okay, but what we care about is the answer, the other answer we get, which is this right here. Here it is. It's these 3. So it's 1. It's x squared minus 2x minus 2. Well, now why? Why did I start with x squared? Well, because we just divided. Just like when you take 30 and you divide it by 5, you get something smaller. You get 6. When you take this x cubed polynomial and you divide it by one of the things that goes in, it brings it down 1 power to x squared. So these 3 numbers that we have left, these are the coefficients, the numbers in front, starting with x squared. Okay, so now we got to break this down, just like when we divided here, we got the 6, we had to break the 6 down further. So now we got to break this down. That's step number 2. Break down the 1x squared minus 2x minus 2 by how? The quadratic formula. Let's do the quadratic formula. This is my A, my B, my C. Well, you don't have to know. You can just use the notes. So this is all, by the way, this is all in the notes. See right here, I'm showing. Step 2, now solve the remaining by the quadratic formula. There's the quadratic formula and all the steps showing in the notes. So let's do it. So here we go. Do a couple steps right now. There we go. All right. So same thing here. So the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we go. So it's going to be negative b. What's b? Right here. Negative 2 plus or minus square root of b squared negative 2 squared minus 4 times a is 1, times c, which is negative 2, all over 2 times a again. All right, so let's get this cleaned up. So this is going to be what? So right out here, we've got negative 2, which is plus 2. This is negative 2 squared. This is 4. Now watch the signs here. You've got negative times positive times negative. 2 negatives, positive 8. Did you see that? Negative times positive times negative. 2 negatives is 8. 4 times 1 is 4 times 2 is 8. All over 2 on the bottom, right? 2 times 1, 2. So we can clean that up a bit. What is that? So that is 2 plus or minus the square root of 12 over 2. Now, how do we clean up that square root of 12? So I don't know if you remember this. I'll be glad to show it right now. How do you clean up square root of 12? You break it down. That 12 looks a little funny. Dragging square root of 12. You break it down. You say, well, it's 4 times 3, and that's 2 times 2. So you break down the 12. Okay. So square root of 12 is the square root. Try that again. Is the square root of 3 times 2 times 2. The order doesn't matter, right? 3 times 2 times 2. Those are all the pieces that make a 12, right? 3 times 2 is 6 times 2 is 12. That is a 12 broken down. And remember, it's a 2-for-1 deal with square roots. 2 2's inside, send 1 2 out, and they're gone. So it's 2 root 3. So root 12 is 2 root 3. That's how you break down a square root. So this right here is going to become 2 root 3. So this fraction is going to become 2 plus or minus 2 root 3 all over 2. Is that good? That's what, by the way, over here, again, this is what square roots always do, right? Think about the square root of 9, which you know is 3. What happened there? What's in that 9? 2 3's inside, 1 3 outside the root, right? That's what square roots always do. So 2 2's inside a square root sends 1 2 outside. That's how we simplify roots. We just break them all down and do a 2-for-1 ship out. Okay, now how do we simplify this? Well, let's just separate it. Let's just say it's 2. No, I'm sorry, I'm getting a little tongue-tied here. Let's just put them both over the 2 like this. Here let me be extra clear with the colors, just so you see what happened. See how that 2 denominator, look, the bar goes all the way. So that 2 is dividing both those guys, isn't it? So just go ahead and separate them. This, the plus or minus is still right here in the middle. That wasn't confusing. Right? Just do that. And so then what does that mean? This is 2 divided by 2. That's just 1. And these cancel. plus or minus root 3, isn't it? 1 plus or minus root 3. So what are our zeros then? Well, we've got the original 0 they gave us, -3, right? That was right in the beginning of the question, right? -3. And then we found the other two, which are 1 plus root 3 and 1 minus root 3, right? That's what these two answers are. So there's the 3 zeros, the 3 places on the x-axis where our graph hits. So these are those other two decimal numbers, but now we know the exact value. It's 1 plus root 3 and 1 minus root 3. If you type those on your calculator real quick, you would find that they're the same as, getting back to it, those numbers right there. The negative 0.732 and the positive 2.732. It's just the decimals go on forever. It's called an irrational number. And so those decimals there are just approximates. So the exact values are right there. So recapping, what do we do? So they give you something like this. They give you a polynomial, and they want you to break it down. They give you one of the x-intercepts, one of the zeros. X-intercept is the same as 0. Those are synonymous. X-intercept or 0, same thing. It's a place where the graph hits the x-axis, or is it a height of 0? Same thing. So what do? You take that first x-intercept or 0 they gave you, do synthetic division, going to get a 0 remainder, then take what you got as your answer, your quotient, take that right there, and then break that down with the quadratic formula, get your two answers. Those are the other two zeros plus the original one they gave us from the beginning. And so there we go. That's how we do that.